Okay guys, I hope y'all are doing well. Here's a quick video on matching systems of equations and graphs, and then kind of reviewing turning linear equations into slope-intercept when you are looking at graphs or trying to match up graphs. So we're going to start with these two equations here. I've got x equals 2 minus 2y, and then I have 4y equals negative 3x minus 4. One of them is in y equals mx plus b. That one is in slope-intercept, but the top one is not. And what we're going to do is we're going to get these into both of them in the slope-intercept and then match them up to graphs and make sure we've graphed the system of equations that we have right here with these two equations. So let me shrink these, let me throw these up at the top. And these are the three kind of choice graphs we're going to have. So we're going to solve and put these in slope-intercept form, and then we're going to figure out which of these three graphs, either 1, 2, or 3, matches or the equations or the system of equations that we have. Okay, so let's get rid of that. So here's what we're going to do. We know we're going to go ahead and make sure that these are in the right form. So we want these in slope-intercept, which is y equals mx plus b. And let's deal with this bottom one first. The bottom equation right over here, the 4y equation, is close. It already has the y at the front, and we only need to do kind of one little step to it to make sure that's in the slope-intercept form we're looking for. So I'm going to jot it down over here. We have 4y, sorry about that, 4y equals negative 3x minus 4. Alright, so what we really want is we want the y by itself. We don't want any value with the y on this one. So we want to get rid of that 4. So what we're going to do is we're just going to divide the 4 out. And so what we can do is if we divide the 4 out there, we have to divide all the other values by 4 to get rid of it. And let's see what happens here. It cancels there. We're left with y equals, getting this in the slope-intercept, y equals, we don't really need to divide the negative 3 by 4. That's just going to leave us with a negative 3 over 4x, which is our slope, as we know. And then we got to do this right here. Negative 4 divided by 4, negative divided by a positive is going to stay negative. So that's 4 divided by 4 would be 1. Negative 4 divided by 4 is negative 1. So that gets us here, and we've successfully converted the second equation we had right there into y equals mx plus b, y equals negative 3/4 x minus 1. Cool. All right, let's do this first one. First one, a little bit more challenging. We still want to get this into y equals mx plus b. So we've got a little more work to do on this one because we've got an x equals situation here. So let's write it down. I got x equals 2 minus 2y. And to start with, we want the y at the front. Right now, the y is right there. I've got a negative 2y. We're gonna bring the sign with it. So it's got a negative 2y. We want to get it around to this side. So we got to do an operation here to get it to the other side. We're going to do inverse operation. So essentially what we're going to do is it had that minus sign in front of it, subtraction, or we could call it a negative 2, but what we're going to do is the opposite of that. So we are going to come into orange here, we're going to do the inverse operation, add 2y to both sides. So add there, throw 2y onto the end there, and let's rewrite this thing. Okay, so out on the left, I've got my 2y plus the x. We still have the x that's right there. It's going to equal, so there was the x, it's going to equal 2, and then this is gone. This cancels out right over there. So we've successfully moved the 2y over. So we got the y part. Now we need the equals the mx plus b. So we need the x part now off to the other side. So how are we going to do that? We're going to do the same thing. We're going to do inverse operations. It says plus x, which is basically like plus 1x. So let's subtract away x from here, and we would subtract it away from over here. So what that's going to look like is we will have a cancel situation there. And I'm going to end up with 2y equals negative x, I'm going to go ahead and put the negative x in front. So negative x like negative 1x essentially, plus 2. And we are almost there. There's one little step we need to do, and it kind of goes back to when we were working on this equation right there. We want it in y equals mx plus b, but we want the y right here by itself. We don't want a number with it. Right now it's got this 2 hanging out. We want to get rid of the 2. So let's divide out 2. Divide out 2 and divide out everything by 2. It's going to cancel there, and I'm going to be left with y equals, when we divide here negative x, which is really like negative 1x divided by 2, we're basically turning in that into a negative 1 over 2x. We don't really need to divide. That's our slope. And then plus, I just have 2 divided by 2. That's pretty straightforward. 2 divided by 2 is 1. It's a positive 1. So I'll put plus 1. And just like that, we've successfully turned that first equation into slope-intercept y equals negative 1/2 x plus 1. So now that we have those equations, which graph that we had is really showing us what we had. So if I go back, we did all this work. We got y equals negative 3/4 x minus 1, and then we have y equals negative 1/2 x plus 1. I put those here. These are 3 graphs. We have 1, 2, and 3. Which graph is the graph of this system of equations? Well, let's check it out. The first thing to always look at, just take a quick peek at your slope real quick. The slope that we have on both of them is negative, which means on a negative slope, you know our line is going to be going this direction. It's going to be going a line, I'm kind of scratching, I apologize, but a line that's kind of going either up and to the left or down to the right, whatever, and they're both negative slopes. So that means both lines would be negative slopes. The only one at the first look that has that is this one, because it has a negative slope happening here, and there's also a negative slope there. That tells me real quick that is probably the answer. But let's double check and let's make sure. So the next thing we'll look at is the B, or the y-intercept. We know one of the lines needs to go across at negative 1y. The other needs to go across at positive 1y. So let's zoom into the one we think the answer is, okay? Let me switch over to a red here, and we should have one at 1y, so it looks like this line is going right across at 1y. That works. And then another one's doing negative 1. So, sorry, I switched the screen on you there. But that's negative 1. That looks good also. So, just to double check the slope, we already know that's the right answer. But to double check on the slope, remember we're doing rise over run. So, the negative 1 line should have a slope of negative 3/4. Negative 3/4. So that means we should going up 3 and then going over 4 to get to another spot. So what I'm going to do is I'm going to use yellow. And I'm going to say, hey, we're going to go from this dot. Keep switching the screen. Let's go from this dot to that dot. And I bet that is a 3 up, 4 over move that we make. Let's count it. So that's 1, 2, 3. 1, 2, 3, 4. Negative 3/4 slope on the first one. That works. On the second one, I'm going to go ahead and erase what we did just to give us some space. On the second one, I've got a coordinate there, and I think we can get one right there too. So it should be, the slope on that one is a negative 1/2. So when we go to that one, it's 1, 2 over 1, 2, 3, 4, and that'd be a negative 4, of which you know reduces down to negative 1/2. So, yes, this one is the best answer right over here. That would be the one we would choose for the answer. And again, we just took those equations, we got them in slope-intercept form, and then we matched them up to the graphs. We found the positive, negative slope and the y-intercept, and then matched up the graphs from there.